turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to The Naked Scientists podcast, the programme that brings you the biggest breakthroughs and talks to the major movers and shakers in the worlds of science, technology and medicine with me, Chris Smith. Coming up, how the latest science helped the Caribbean prepare for Hurricane Melissa, the alcohol-free beers that still provide a buzz but without the hangover, and why a German warehouse is simulating a European moon landing. The Caribbean is reeling in the aftermath of one of the fiercest storms to ever hit the region. Hurricane Melissa tore through Jamaica with winds of up to 115 miles an hour, flattening homes, cutting power and leaving streets flooded. Neighbouring Haiti and Cuba were also hit very hard by the Category 5 storm, with casualties reported in all three nations. Meredith Garofalo is an award-winning meteorologist in the US, and she's been tracking Hurricane Melissa.
The maximum sustained winds with this storm got up to 300 kilometers an hour. To give you an example, you have like the island of Jamaica. I mean, this storm was so big, even if it didn't make landfall, it could still cover the island with the width of that. So now it's moved past the Eastern Caribbean islands and it is approaching Bermuda. So later, as we go into the next 24 hours from when this was recorded, it will approach Bermuda as a hurricane. This is a weakening after it becoming one of the strongest Category 5 hurricanes we've ever seen in the Atlantic Ocean.
Meredith Garofalo there. But what exactly is a hurricane? Nadia Bloemendaal is an expert on extreme weather events at the Royal Netherlands Meteorological Institute.
So hurricanes form out of a cluster of thunderstorms. Most of them come from the African continent and then they move out over the open Atlantic Ocean where they get in contact with the warm ocean waters. So if this warm ocean water is above 27 degrees Celsius, that means that there is enough energy for that system to start growing and to start intensifying. Now, there are a couple more factors actually to it. If you have ever seen a satellite image of a hurricane, you might have noticed that the hurricane is spinning. So this spinning is caused by the rotation of the Earth, which is called the Coriolis effect. And if this Coriolis effect is large enough, it means that it can get that cluster of thunderstorms to start rotating around its own axis. Now, once that rotation is in place and they have that energy source coming from the ocean, that's when this cluster of thunderstorms really can start growing into a hurricane and then later a mature hurricane. But there is one final ingredient which is really essential for a hurricane, and it's actually an ingredient that the hurricane does not want, and that is vertical wind shear. So vertical wind shear is the difference in wind speed between the surface and high up in the atmosphere. When that difference is very small, it means that the hurricane can stay intact and move forward basically in one piece. But when that wind shear is very large, meaning that there's a lot of wind high aloft, the top of the hurricane gets blown apart, and that's when it loses that structure, and that's when it starts falling apart. So this final ingredient that's very key to hurricane formation and hurricane intensification is wind in the atmosphere around it should basically be absent.
So the key driver then is that warm water in the Gulf of Mexico. That presumably is warming air and also saturating the air. You've got lots of wet, rising warm air, which is going to drive these storms. Does that mean then that if we have higher sea temperatures, we're going to see higher storm intensities and possibly also more of these sorts of storms?
Yeah, that's exactly right. This 27 degrees Celsius, that's really the lower threshold. But everything above that 27 degrees Celsius basically translates to more energy for the system. In the case of Melissa, Melissa was located in the Caribbean Sea over seawaters that were 30 degrees Celsius. Now, 30 degrees, we're talking about super fuel for a hurricane. And once Melissa got a hold of this whole structure formation and started drawing this energy out of the ocean, these 30 degrees Celsius temperatures just made Melissa basically explode in terms of intensity. So within 24 hours, Melissa intensified from a tropical storm to a Category 4 hurricane. This is a process that we call rapid intensification. And rapid intensification, its definition is that a tropical system increases with 30 knots or 15 meters per second in 24 hours time. In the case of Melissa, Melissa actually increased with 60 knots. So that's double the definition that we have for rapid intensification. And this increase was driven by these 30 degrees water. So sea surface temperatures and increasing sea surface temperatures under climate change means that we're going to be seeing more of these rapid intensification events. So hurricanes exploding to higher categories in much shorter timescales. That means that you are going to see more of these major hurricanes, Category 3, 4, 5 hurricanes towards the future.
I suppose one silver lining to the clouds, though, is that I was seeing reports last week, well before any of this occurred, predicting this and also predicting, as it turned out extremely accurately, the path that the storm is going to take. Now, that must have translated into people being able to take avoiding action, being able to batten down the hatches in order to defend themselves better. So we appear to be getting some things right. We've got a lot better at invoking the mechanisms you outlined and then using them to forecast and predict these sorts of things.
Yeah, you're very right. And this is all massive credits to the meteorologists working at the National Hurricane Center. They are so skilled in analyzing the weather forecast, what's coming out of these numerical weather models, and translating that to what's actually going to happen with this hurricane. Now, the thing is, weather models have a hard time capturing this rapid intensification, particularly if we're talking about tropical storm to Category 4 type of events. This is all ingredients need to be there. It all needs to be perfect, and that's very hard for a weather model to capture correctly. But these meteorologists at the Hurricane Center, they have the experience to see that, wait, all these ingredients are in place. That means that we're very likely going to be seeing a rapid intensification event. You were also talking about the track. It was already clear, what is it, like the Wednesday or Thursday in advance of Melissa's landfall, which occurred on Tuesday, the week after. Melissa was targeting Jamaica. So that means that 5-6 days in advance, people could already start preparing for the arrival of this hurricane. The government made these shelters available for people who wanted to evacuate. They had time to prepare for this. And that's so of the essence, to have these early warning systems in place to warn people a few days in advance, because that saves lives. Melissa was one of the worst events that could ever happen. It was catastrophic. But I feel very strongly that the fact that there was so much time to prepare and that people prepared for this event, that might have actually saved quite some lives in the end.
And that's the power of prediction. That was Nadia Bloemendaal. She's at the Royal Netherlands Meteorological Institute. Earlier this year, a 53-year-old British woman died after receiving black market weight loss injections at a beauty salon in Manchester. Karen McGonigal was given several unlicensed injections without medical training and controls that come with prescription drugs like Ozempic and Mounjaro. And in the last week, police raided a production facility and a house in Northampton that was making knock-off weight loss medicines without, of course, any of the normal safeguards employed by the pharmaceutical industry. Professor John Wilding is an expert in obesity and diabetes medicine, and he's been involved in the trials of some of these legitimate weight loss agents. He's at the University of Liverpool.
There is a lot of people trying to sell products that may or may not contain the active ingredients within these weight loss medications that have not been produced according to good quality pharmaceutical standards, good laboratory practice, and so on, and manufacturing practice, and therefore may contain either other substances that could be toxic or certainly may not contain the right amounts of the active ingredients. And that is potentially extremely dangerous.
Obviously, the wider question is, why is this happening at all? Why is there a huge market for illicit agents? The police say this was the biggest stash of weight loss jabs ever discovered being made illicitly in the world so far. But why is there such a huge demand?
Firstly, because as a doctor who treats people living with obesity, I recognize for many people, they've tried really hard, often for much of their lives, to try and lose weight. But it's really hard to do that with just diet and exercise, because we know that the body tends to kind of fight that and take you back towards where you were before. And these medicines are very effective. They help people lose weight, sometimes up to 15 to 20% of body weight. But the difficulty that we have is that most of the prescribing that's happening at the moment in the UK is in the private sector, partly because the NHS, although it has approved the use of these medications, has, for financial reasons, restricted that to a very small group of people with really quite severe and complex obesity. But there are literally hundreds of thousands of people who are potentially eligible, but who currently can't obtain these medicines on the NHS and may be unable to afford the quite high prices that are currently being charged for obtaining the legitimate versions of these medicines. And so therefore, some people are just so desperate that they're going to these apparently cheaper sources that are not the correct active ingredient. And there is a very real danger in that.
Hard to see, though, what we can really do about that, isn't it? Because obviously the pharmaceutical companies have a price point, and if people can't afford it, and you've got people coming along saying, well, I'll knock some up in my kitchen, might not be great, but you can try it, there's always going to be a demand there then, isn't there?
And I think that is absolutely the crux of the problem. The development of these drugs is not cheap. It costs billions of pounds to develop a drug. You have to go through very complex and large and long clinical trials. And of course, that means that the costs of developing these drugs have to be recouped. And that's why the companies charge what they charge. I don't personally have a problem with that. What we do know is that when we look at the cost effectiveness, which is the way that the NHS decides whether it can afford to use these medicines, because of the benefits they have, they are deemed cost effective. And yet we have this problem. The NHS is being highly restrictive about who can access these medicines, because the large numbers of people means that although it's cost effective, the affordability, it just isn't there at the moment.
It's a year or two since you and I first began to talk about these new agents or newer agents, which have seen a number of regulatory changes over the time in terms of who can get them and that kind of thing. We're slowly accruing quite a lot of data on who's using them, the benefits, and what happens slightly longer term.
Yeah.
Has your view on their use changed, or what are we learning now about long-term use of these agents?
We are gradually gaining more and more information about long-term use. In the field of type 2 diabetes, we've been using drugs in this class for 15 or more years now. So we do have a lot of data at the lower doses that are routinely used to treat people with type 2 diabetes. But what we're also seeing from the clinical trials is long-term data in people with obesity without diabetes. For example, one trial with the drug semaglutide treated people with at high risk of cardiovascular disease. So these were people who'd already had a heart attack or a stroke, and they were treated with semaglutide or a placebo for 4 years or more. And that gave us a lot of long-term safety data. And that was 17,000 people. And it showed a reduction in cardiovascular events in those patients treated with semaglutide compared to those treated with placebo. These are real clinical benefits that make a difference to people's lives. That sort of additional evidence is really helpful in understanding how we can and should be using these drugs in the long term.
Returning to how we began this conversation with a situation where we have a pricey product that does have efficacy attached to it, is out of the reach of people with a very, very common and increasingly common condition, and that's being overweight. What do you think the answer is?
I would like to think that this will be hopefully a relatively transient phenomenon. The reason why I'm optimistic is because for two reasons. One is that, as with all medicines, after time they come off patent, and in some countries, for example, semaglutide will be coming off patent next year, and that means that other companies are able to produce it, and that tends to bring down the cost. So certainly once we get what we call generic copies, which are approved, properly manufactured, then that will tend to make the cost come down. The other thing that is happening is that there is huge amount of research going on into other agents that work in a similar way. And we already know within the pipeline that there are probably going to be 4 or 5 more medicines approved within the next couple of years. And that is very likely to increase competition, which will tend to, again, bring down the price. The other point is that some of these developments mean that we also have agents that don't have to be given by injection, that are tablets that are perhaps maybe cheaper to make. So I'm optimistic that things will improve, but it might take a few years to reach that point.
The University of Liverpool's John Wilding there.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
This is The Naked Scientists with me, Chris Smith. Still to come, the European Space Agency is simulating what it takes to deliver supplies to the moon. But how are they doing that? Before that, though, alcohol-free beer has come a very long way in recent years. The watery lagers that once resembled fizzy pop have given way to a new generation of more scientific brews that claim to deliver not just the taste, but can administer chemical relaxation too. One of the latest and most innovative entries, Gabir, has been developed by the neuroscientist David Nutt.
So Gabir is a new functional beer, but the name is a pun on beer and GABA. And GABA is the molecule in the brain which alcohol works on to keep you relaxed and calm. Primary effect of alcohol to improve sociability and conviviality is by enhancing GABA. So our company is called GABA Labs, and we are working with various molecules, largely botanical, but also synthetic, to mimic the effects of alcohol. And currently, we are selling Gabirs, which are alcohol-free beers that have the flavor of classic beer, but which have the functionality induced by herbs, which promote GABA in the brain. And that helps the people who drink them get the effects that they want from alcohol, and which they do not get from alcohol-free beers.
Are they alcohol-free? Because some people will argue, well, you need a bit of alcohol there because it does contribute to the flavour and the volatility of a beverage.
We have gone for the very, very low alcohol level, which is still designated as alcohol-free, because we want the best taste. So our beer and our stout are brewed in the classic way, and then the alcohol is taken out. So there's just a small residual of alcohol. And as you point out, that probably also contributes a little to the mouthfeel and the taste and the volatility. So you get maybe that little bit of that first impact on your senses before the botanical ingredients go into your stomach and then into your blood and then into your brain.
When are the botanicals added then? The things that produce the conviviality, as you, I love that word, put it. Do they go in after you've made the beverage and taken the alcohol out?
Gabir is actually a real Arabic word. It means learning. It is a botanical liquid which we have developed over many years to mimic the effects of alcohol. We've put it into other drinks. Some of you may know of our first drink, which was called Sentia, which is a series of interestingly flavored spirits. Then we've moved on to take out of those key ingredients that produce the functionality, and we've called them Gabir. We've also been able to put them into an alcohol-free whiskey, which is called cask. So these botanical ingredients give people the functionality that they're looking for, but without the harms of alcohol.
What was the insight for finding these things? Did you rationally search for these herbs, or did you hear a whisper on the grapevine from traditional folk knowledge that this could do this? How did you discover this particular combo in the first place?
We searched biochemistry databases, botanical databases, to find herbs that contained compounds which were known to enhance GABA. And then the second step was to select ones that are already in the food chain so that they're approved as food or food supplements. So we could then put them into drinks and market them as botanical beverages with a functional effect.
Is this completely legal, as in unregulated, and you don't have to worry about someone coming along and saying, well, you're drugging the population if they drink this and this is now a Class A drug or something? How do you get around that?
Well, these are botanical herbs. You can buy them and eat them. All we do is put them into a liquid so you can drink them.
And there's no long-term health consequences, there's no hangover effect, there's no onward impact. as it were. They just have a here and now effect on the GABA system in your brain.
People haven't been drinking our drinks for tens of years, but the fact that these herbs are approved as foods means that the authorities have decided that they are safe if they're used on a regular basis as foods. So our supposition is that they will have similarly little negative effects in the long term if they're used in drinks. And one of the real benefits of these that people often comment on is the fact that you do not get hangovers because they do not produce the inflammation in the body that alcohol does. And also you don't get very drunk and you don't get very angry, and they don't seem to cause addiction because they don't target the other chemicals in the brain that alcohol works on to give its unwanted effects. We can minimize the harms of drinking.
How quickly does it start to kick in? How long does the effect last for? How intense is the effect?
It doesn't matter how much of this you drink, you will not get blind drunk, you will not have blackouts, and you will not have hangovers, because we have made these botanical mixtures to produce what we call a plateau effect. So there's a maximum they can achieve, and however much more you drink, you won't exceed that. The effect will last longer, but you won't get a greater effect. The drinks are constructed so that the effects come on within 10 to 15 minutes, and we do that using other herbs. So as well as the herbs which give you the effect, we also put in other herbs which accelerate the uptake of the active ingredients through the gut and into the brain. The effects are designed to be relatively short-lived, so generally they last for less than an hour.
There's a claim that if you drink fizzy beverages like champagne, it makes your stomach empty faster, so you get drunk quicker. Are you going to make some champagne? I mean, is that true?
It is true. No, fizzy drinks accelerate the uptake of alcohol, which is why it's quite dangerous to drink fizzy drinks at the start of a drinking bout, because you get drunk faster, so you start to lose control sooner. Actually, a lot of our customers use fizzy mixers with Essentias. In fact, with the cask, the whiskey alternative, I like to drink cask with a caffeine-free cola.
What's the market looking like, and how big could this get? And can you protect this? As in, what's to stop me taking your drinks, shoving them in some very good analytical equipment, working out what your molecules are, and then just ripping them off?
I mean, you could mix the herbs together, as we've done, but you don't know the exact amounts. That's a trade secret. And why would you? Much better to do what companies are doing now, which is coming to us and saying, please, can we put your active botanical ingredients, your gabirs, into our drinks? We've been approached by 2 global drinks companies to see if they can improve their alcohol-free beers by adding in our ingredients. So yes, you could try to do it. It's very difficult. It's taken us 6 years. So it would take other companies quite a long time. And by the time they've got to where we are, we're likely to have moved on quite a lot further in terms of having more specific, more powerful ingredients, and ones with even less colour, so we can put them into vodkas and Bacardis, etc.
A tasty proposition from David Nutt, who's at Imperial College in London. Imagine this. You think you're standing on the dusty, grey surface of the moon. The sky is pitch black and only crisp stars are glinting above. But this isn't the lunar surface. It's actually a warehouse near Cologne in Germany, where the European Space Agency will be putting a next-generation lander through its paces. It's called Argonaut, and it's an autonomous cargo vehicle designed to deliver more than a ton of supplies to the moon. The race to return to the moon is certainly gathering pace. And Richard Hollingham from the Space Boffins has the Odyssey.
Argonaut is your standard lunar lander, if there can be such a thing. So legs, a chunky body, and very much like one I saw the other day, actually, in Pittsburgh in the US, where another company is developing a lunar lander, a company called Astrobotic. So the European Space Agency one, big chunky sort of base for its lander. What's neat about it is it's essentially a truck that can carry a payload. So the second section, so there's the sort of base part of the lander with the power systems, the propulsion system, solar panels, all that sort of stuff. And then on top, what they can carry is components perhaps for a lunar base, lunar rovers, power supplies, food. The concept is for a delivery truck. I have to say, though, it's not been built yet. They built a lovely model. It has not been built. It's not ready to fly. It's not there. This is part of a slow progression. But what the European Space Agency has done is build the moon in Cologne, Germany. You know, they've got this warehouse. I'm desperate to go and see it. I've not seen it in person yet. They've got lunar dust. They can test their lander there. They've got a rigging system where they can have astronauts moving around in spacesuits, sort of simulating the gravity on the moon. They're a step ahead of the rest of the world in that respect.
How will landers like this actually get to the moon, though?
The European one, Europe's got this new substantial large launcher called Ariane 6, which is a bit of an old school rocket, really. But it's big. The Ariane launchers have launched amazing things. The predecessor launched the James Webb Space Telescope. It's a great, reliable launcher. So it's their rocket, their lander, getting their stuff onto the moon. With the US, there are a lot of small companies. NASA has really hedged its bets on Starship. This is this giant rocket you might have seen that Elon Musk, his SpaceX company, has developed. It's the one that goes up, occasionally explodes. It's gradually getting there. It's also the one you might have seen that spectacular image of it being grabbed as it returns, as the main booster returns to Earth. I mean, it's phenomenal technology, but it's really not there yet. And it's quite a complicated process. So they have to launch into orbit around the Earth and then refuel with another spacecraft, then head to the moon, then rendezvous with the Orion capsule, which has been built separately, and then land on the moon. It's all quite complicated. None of that has happened yet. And so the goal of landing Americans back on the moon by 2027 is almost certainly not going to happen. And what's happened really now just in the last week or so, the acting administrator at NASA, Sean Duffy, has said that essentially that they're looking for other landers. So I think it's going to be a bit of a scramble, because this is really turning into the US and its partners, including the European Space Agency, versus China in terms of who will land humans back on the moon first.
The initial intention then with things like Argonaut, it's like the Mars yard, but it's the moon yard, isn't it? It's the equivalent of the moon in Cologne. What's the idea then? They will put down a lander and the lander will deploy a rover, and the rover stakes Europe's claim to a bit of the moon surface? What's going to happen?
Europe is part of this big collaboration. It's called the Artemis Accords, with NASA, with America, with Canada, with Japan. And so this is quite an interesting development in that Europe is looking at, well, can we do this alone? What can we do on our own? Or what can we do with perhaps other partners? Because the fear is that the United States, with the current administration, is becoming an increasingly unreliable partner. And it's not entirely clear what these collaborations with NASA, whether they will continue. So I think this is a way of saying, well, look, Europe's got its own rockets. We've got the capabilities of developing landers, and having this facility in Germany certainly gives them a head start in terms of operating, walking on the moon. I think that this lander concept is really neat because it is interchangeable. You could put all sorts of stuff on it. You could put your components for a moon base. You could send your robots up. You could start building your moon base and then send the astronauts. Ideally, this would all be an international collaboration.
And what's the timeline? Or isn't there one yet?
There isn't one yet. I did have a look on the European Space Agency website, couldn't find one. To be fair, though, there is a European-backed mission launching early next year, it's due, which is a communication satellite developed by the UK company SSTL, and that will provide communications from the moon. They're also looking at global positioning from the moon. So this kind of infrastructure around the moon to support activities on the lunar surface.
We've dwelled on what NASA aren't doing. We've looked at what ESA, European Space Agency, are doing. What does the Chinese situation look like? Are they on track? Have they made any noises about what their plans are and by when?
The thing is, and this has been true from the very beginnings of the space age, we only ever hear of Chinese successes. We rarely hear, unless they're in public, of Chinese failures. So whilst we can see Elon Musk, SpaceX, Starship blow up, we won't see the equivalent with China. So we don't know day to day any of the problems they are facing. What we only hear about is Chinese successes and Chinese ambitions. They've landed a rover on the moon. We've seen the pictures from that. Absolutely spectacular. They've got a space station. They've got astronauts in space right now, but we don't know how far advanced their lunar plans are and what sort of timeline they are likely to set. It's almost certain they would love to beat the Americans to the surface of the moon. Going to be a very tight race now, which is why the United States is looking at alternative landers to get humans, its humans, on the surface of the moon.
Do we know when we might realistically be looking at that? Because originally people were saying it's going to be sort of this year, next year, pretty soon, any time now. And now that seems to have been kicked down the road a bit.
Well, the administration in the States has made it clear they would like it to happen during Donald Trump's term as president. So, we're looking, that's the next 3 years, potentially.
Exciting times. That was Richard Hollingham at the Space Boffins, and you can hear more about Richard's visit to see Astrobotics lunar lander at their factory in Pittsburgh in the latest Space Boffins podcast. That's due out early next week. If you subscribe to the Naked Astronomy podcast, you'll find it. Well, now it's time to take a walk on the wild side, and we better make it a brisk one for Question of the Week. James Titko.
We are all familiar with the 10,000 steps goal. But long-legged people take fewer steps to cover the same distance as people who have shorter strides. Heavier people need to use more energy to take a step than a lighter person. So are all steps created equal?
It seems like sound logic, John. Exercise is obviously hugely beneficial for our health, whether it be reducing our risk of heart disease or dementia to improving our mood. But it would make sense that the right amount of physical activity to reap its raft of rewards is probably going to depend on your individual circumstances. Helping us to answer this week's query is Raj Amonani, consultant in sports and exercise medicine. First of all, that 10,000 steps goal you mentioned, John, where does it come from?
There's a lot of theories as to where that number came from, but I think the one that's agreed amongst most people is that it actually, interestingly, came from a Japanese advert in the 60s. They were selling a pedometer to help people track their step count. And I think they figured 10,000 was an easy step count to remember, and most people could hit it with some effort. So I think that became legend and lore over the years. But there's been lots of research and studies since then that has said probably 10,000 isn't that magical number as we all once thought and believed. And as the question said, how we walk makes a big difference to how much energy we exert. So things like step length, body size, your weight, and how efficiently you walk really can change how much energy you're using. So as you said, two people walking 10,000 steps certainly does not mean the same level of exertion or the same level of benefit even.
This begs the question, if the nature of the physical activity someone has to do to benefit their health varies from person to person, how should they be able to know they've done enough?
I think a really good place to start to answer that question is the Chief Medical Officer Guidelines on Physical Activity. So I'm sure a lot of the listeners will be familiar with this, but the UK government put this out a few years ago based on evidence about how much exercise we should be doing. And the general consensus was that we should try to be getting 150 minutes of moderate intensity exercise per week or 75 minutes of vigorous intensity exercise per week. People get really worked up with health trackers and wearables around this, but I think there's a really simple way to break it down, and we call it the Sing Talk test. And essentially, it's the level of breathlessness you get to a point where if you can talk whilst you're doing an exercise, that's probably low intensity. But if you can do the exercise and not sing during it, that suggests that you're getting into more kind of the moderate, closer to vigorous intensity. So that level of shortness of breath is a really easy way to figure out how intense your exercise is. This actually links to a really nice study that was published a couple of weeks ago in the Annals of Internal Medicine, that looked at almost 30,000 people across a couple of countries to look at actually, is it the volume of steps that we're doing or is it the intensity? And what they interestingly found that actually shorter bursts of brisk walking, so 10 to 15 minutes of higher intensity walking, does reduce our cardiovascular risk and all-cause mortality risk by quite a significant amount, even if you're not doing 10,000 steps, for example. So actually people who are doing 4,000 to 7,000 steps at a higher intensity, a shorter burst, actually may be doing better than those who are doing 10,000 steps at a really slow intensity.
So John, 10,000 daily steps, while certainly no bad thing, is probably not the most efficient way, scientifically speaking, to better your health through exercise. You're right that heavier people use more energy per step and thus need fewer to enjoy an equal health benefit, but they, like all of us, would perhaps be better off with a few short jogs or maybe some simple weight exercises to get their heart rate up. This, research suggests, would be better for their heart health. Thanks to Raj Amanani, consultant in sports and exercise medicine, for helping us with that answer. Next time on Question of the Week, we're answering this from Paris, voiced up by Will.
What determines how long a fetus gestates for in humans and other animals?
And if you have a question or an answer for us, why not send it in? It's chris@thenakedscientist.com. You can also pop over to our forum, that's at nakedscientist.com/forum, and find the Question of the Week section there too. Next time, we're going to be taking you behind the scenes at the National Physical Laboratory. They're celebrating their 125th birthday, so we'll be catching up with their timekeeping, quantum mechanics and AI roles. The Naked Scientist is supported by Rolls-Royce and also by all of you out there who support us with financial donations to help us out with our running costs. And if you appreciate what we do and you'd like to chip in, it really does make a massive difference and we are extremely grateful. Please head over to nakedscientist.com/donate for details of how you can do that. And thank you very much to those of you who already do. I'm Chris Smith. From all of us here at the Naked Scientist team, thanks for listening. And until next time, goodbye.